Hello everyone, it's Sachi back again with another video. This is number 16 in this AP Physics C Mechanics multiple choice test. The last in a set of 3 problems relating to this scenario, which reads, a ball of mass 2 kilograms is thrown vertically upward from the top of a building. The ball's velocity v is given as a function of time t by v of t equals r minus st, where r equals 5 meters per second and s is equal to 10 meters per second. The positive direction is upward. And problem 16 is, if the ball reaches the ground at t equals 2 seconds, what is the height of the building? So again, let's go back to our equation for velocity. So we can plug in the values it gives us to get v of t is equal to 5 minus 10t. So what we ultimately want to do is find the height of the building at 2 seconds. So what we can do from this velocity equation is take the antiderivative of it to find an equation for height, for position. So just as velocity is the derivative of position, acceleration is the second derivative of position, and the first derivative of velocity, position is the antiderivative of velocity. So let's find an equation for height as a function of time being the antiderivative of this function. So 5 is equal to 5 times t to the 0th power. So let's add 1 to that, 5t. And then this works. The derivative of 5t is 5. So now for 10, we're going to add 1 to the t, so it's going to be t to the 2nd power. And then now we have to say what coefficient of t times 2 is going to give us negative 10. And the answer here is negative 5, because if this is our antiderivative. If we take the derivative of negative 5t squared, we multiply the 2 by the 5, you get negative 10t to the first power. And then, of course, as we're taking the antiderivative, we're going to add c as a constant, because this constant would disappear. It would become 0 in this function, so we have to account for that. So what is the height of the building? What it tells us is the ball reaches the ground at t equals 2 seconds. And when the ball reaches the ground, that means that the height is 0. So let's plug in t equals 2 seconds. Height as a function of 2 seconds is equal to 5 times 2 minus 5 times 2 squared plus c. When we multiply this out, we get 10 minus 5 times 4 plus c is equal to negative 20 plus c. But here, the ball should reach the ground, so the height should be 0. So let's set this equal to 0, and then solve for c. 20 equals c. And again, let's look at what c means in terms of this equation. C, the constant in our antiderivative function, is going to be the height of the building, because at time 0, the height starts at the height of the building before the ball is thrown upwards. So from this, we know that D is the correct answer, 20 meters. That is our height of the building based on using derivatives and antiderivatives as well as projectile motion to solve this problem. Yeah, again, fairly straightforward. We just have to remember to think of derivatives and antiderivatives when we're given velocity up here and we're asked to solve for height. It's another one of those things where you've got to think about transitioning between the two, between acceleration, velocity, position. So that's how you do this one. Thank you for watching. Next, we're going to move on to problem number 17. But for now, please drop your comments if you have any questions, concerns, thoughts on this video. Let me know. Yeah, pretty straightforward problem as long as you do that. Just make sure to pay attention to those derivatives, antiderivatives, what the problem is asking you, and you're good. Thanks for watching.